In this video, we are going to focus on any problem when operating microservices for large-scale applications. You can see the image way of learning the course flow. We have design, adapt, and evaluate the current architecture. Now we are going to define and identify a new problem with the current architecture. In this step, we will ask what's wrong with this current architecture and how can we improve the current design. So the problem is fault tolerance microservices able to remain operational for any failures or disruption, recover from the failures. So this is the pain point of our application, to the fault tolerance of microservices and able to remain operational for any failures or exceptions, and it should be recovered from the failures. So our e-commerce business is growing with highly increased traffic in terms of the concurrent user counts and requests per second counts. We said that now we have almost 1 million concurrent requests accommodated from our architecture. So we should handle and process millions of requests in an acceptable latency with the better performance. And at the same time, business teams able to deploy new features immediately in order to compete the market. But in some cases, due to heavy traffic, microservices got exceptions and broke some major use cases that cause lost revenue and create big crisis to customer loyalty. And this is really important topic. To microservices should be remain operational for any failures or disruption and recover from the failures. So here you can see the considerations. Business teams wants to deploy new features immediately without affecting the system general behaviors, and use cases should remain operational works and available to users. After deployment, if something goes wrong, system should recover from the failures and provide ability of a system to withstand. For example, there will be transient error like server outage or network issues. So microservices architecture should be designed to be resilient in order to ensure the reliability and availability of overall system. This is important because microservices systems typically consist of many independent components that communicate with each other over the network connections, and any issues with these components or connections can impact the system of the whole system. So microservices should be able to withstand and recover from the failures or disruptions such as the server outage or network issues or any transient errors. Microservices should be fault tolerance. So this is so important to ensure the system remains operational and available to users. In order to provide these features, we have a set of solutions, and these are the listed on the slide. You can see that we should learn microservices resilience, observability, and monitoring. And it will be start with the microservices resilience and fault tolerance. That means we will learn retry pattern on microservice communication, circuit breaker and bulkhead patterns on these communications, and so on. And after that, we should learn microservices observability with distributed logging and distributed tracing features. These include Elastic Stack, which includes Elasticsearch, Logstash, and Kibana, and also include microservices distributed tracing with OpenTelemetry and using Zipkin. And lastly, we should identify and learn microservices health monitoring with using the Watchdog, and Kubernetes health monitoring with using Prometheus and Grafana. So we will continue to learn all these concepts in the next section.